Hello there, welcome back to my channel. Thank you for watching this video. My plan for today is to do problem number 1 of 2025 Physics MCQ paper. Now, a disclaimer, I don't have the English medium official exam paper with me. I only have the Sinhala medium one. So what you're seeing here is a direct translation from Sinhala to English. I don't have the actual English paper with me. So, however, if you have the English medium physics MCQ paper, please email that to me. I have provided my email address in the description, or share it as a Google Drive link. I highly appreciate that because I don't live in Sri Lanka, I live in USA, but still these A-level problems are top quality problems that I give my students here in USA. Okay, so let's look at problem number 1 of the 2025 MCQ paper. So now you can see the problem. It reads, which of the following does not represent a unit of energy? Okay, the question again, which of the following does not represent a unit of energy? So let's look at the first choice. The first choice given is kilograms, meters squared, and seconds to the negative power like 2. Okay, so if you look carefully, now you need to identify each term. So this kilogram unit, that's like mass. So if you think about that, that's the units of mass. This is a unit of mass. And then this one, meter squared per second squared, we can write this, if you think, we can write it in this way. Okay, now then you should be able to identify that unit. So that's the unit of velocity or speed. So this is speed squared, speed squared. So that entire term, you could replace that in terms of like variables, like physical quantities. You could say that's like v squared. So we have the units of m and the units of speed or velocity squared. What is this term? Like m times speed squared. So if you just multiply it by some sort of a constant k, then let's say that k is equal to 1/2, then you can see our term, it becomes 1/2 mv squared. So then what is 1/2 mv squared? 1/2 mv squared is what we call kinetic energy. So this is kinetic energy. Kinetic energy of an object. So that's like energy due to motion. If an object is changing its position with respect to time, that is, it's in motion, then we can attribute, we can connect an energy to it, which we call the kinetic energy. So this is units of energy. So this is not the right choice. Okay, so 1 is not the right choice. So just keep that in mind. Okay, so first one is not the actual answer. So now let's look at the second one. I hope you got this idea. Okay, so I'm going to go through all the 5 and then tell you which one is the correct one. So number 1 is not the answer. Let's look at number 2. WS. So what's W? That's watts. So second one is watts seconds. So I'm going to do it here. Second one, watts times seconds. So we want to make sure that is this units of energy or something else. Okay, so let's see, what's watts? So the physical quantity that's connected with this SI unit, that's what we call power. P stands for power. What is power? Power is the rate at which energy is transferred. Okay, the rate at which energy is transferred is called power. Or there's another way to define power: the rate at which the work is done. The rate at which work is done on a system, or work is performed on a system. So that's also called power. So we can define power as the rate of energy transfer from one system to another system. E stands for energy, and this T stands for time. Rate of change, right? Whenever there's a rate involved, you have to remember that it's like per seconds. With respect to a unit time, what's going to happen to that physical quantity? Is it increasing, decreasing, unchanged, like that? And then there's another way to define power: the rate at which work is performed. So instead of W, I'll write work, because we already have a W here, that's watts. So work divided by time. So that's how we define power. Okay. So then let's look at seconds. Again, these are SI units. So look at the physical quantity that corresponds to that SI unit. The physical quantity would be time. So watts seconds is power multiplied by time. But we know power can be written as energy over time. So I'm going to rewrite power as energy over time. And then, so there's a multiplication over there. So that's time. And then can you see this time in the denominator and the time in the numerator, they cancel out. So we get energy. We get energy. So this implies that our second choice is also units of energy. Units of energy. So again, second one is not the right answer. First one is not the right answer because it's units of energy. Second one is not the right answer because, as you can see, it's again units of energy. The question is asking which of the following does not represent units of energy. So both number 1 and 2 represents units of energy. So then let's look at number 3. Number 3, kilowatt hours. kWh, kilowatt hours. So kilowatts, that's a unit of power. That's a unit of power. Simply stated, this is a unit of power. Kilo is what we call a prefix, like kilo, milli, mega, giga, like that. It's called a prefix. So kilowatt, just like in the previous case, you can see like watts is the SI unit, kilo is the prefix. So this gives the units of power. And H stands for hours. So that's a time, a measurement of time. So this one is T. Again, you can see it's P times T, just like the second choice, we get PT. And you should remember again, power can be defined as the rate at which energy is transferred. So E over T, that's power, multiplied by time. So the time in the numerator and the denominator, they cancel out. And our answer is E, energy. So kilowatt hours, actually it's not a unit of power. Sometimes there's a misconception. Some students think that this is a unit of power. No, it's not a unit of power. It's a unit of energy as stated here. And this is how when you have your electricity bill at home, you get an electricity bill, a monthly electricity bill, and that's how you are billed, depending on the amount of energy, electrical energy that you consume. That's how the bill is prepared. It's the same thing in Sri Lanka, as well as it's the same thing in USA. We need to pay our electricity utility bills, and if it's the electricity bill, We also get like the amount of electrical energy consumed per month, and according to that we pay our electricity bill. So again, choice number 3 gives us the units of energy. So that's not the right choice. Okay, this is units of energy. So as a summary, I'll put like number 1, the choice number 1, and no, that's not the right answer. Choice number 2, again, that's not the right answer. Then choice number 3, again, that's not the right answer. Let's look at choice number 4. Okay, and I'm going to do the review here. Choice number 4. So that's like VAS. VAS. Again, these are SI units. So what I'm going to do is then I'm going to replace these by their physical quantities. That's volts. Okay, that's volts. So the corresponding physical quantity is the voltage, or we could call it the potential difference. So again, it has the symbol V. So I'm going to put V. I is amperes. So I'm going to replace A is like amperes. Sorry, A is the units of amperes, and that's the physical quantity corresponding to that is I for electric current. And then this S stands for again seconds. The physical quantity that corresponds would be T, time. So VIT. Again, if you remember like electrical energy and electricity, current electricity, you must have done an equation like this: P equals VI. P equals VI. The electrical power consumption of an electrical device, P equals VI. So again, VI stands for power. VI stands for power. So remember that. So this is power. Why? Because we have a relationship between power, voltage, and the electric current called P equals VI. So from there I can replace VI by T, VI by P, power, and then T is time. And this is just like number 2 and 3. You can see this is the rate at which energy is transferred, or the rate at which work is done, energy over time, and then we have time, and time cancels out. Answer is energy. Okay, so again, this is units of energy. So number 4 is not the answer. So then obviously we have only 5 choices. So then it must be the 5th one. The 5th one is the correct one. So, simply using the method of elimination, you can get the answer. But just to make this complete, I'll just show you, do an analysis for the 5th choice as well. So number 5, let's look at number 5. The choice number 5, the units would be coulombs, voltage, like coulombs, volts, per seconds. Okay, so let's look at so C stands for coulombs, right? So coulombs is the unit. The corresponding physical quantity would be the amount of charge. That's again volts. The corresponding physical quantity would be voltage. And then this is per seconds. So that's going to be per time. We could like take this to the denominator and put it like that, time, because seconds is the unit. The corresponding physical quantity would be time. So that's how I have time. And again here, if you remember, it's all about do you remember the equations? Do you remember the concepts? So Q over T, charge over time. What is charge over time? Charge over time is what we call the electric current. Electric charge over time is the electric current. So Q over T times V. So this is electric current, I, and that's V. So Q over T, that's electric current, and V is the voltage. So again, this is our usual, you could like the order of multiplication, it doesn't matter. So we could write VI, and that's actually P, right? VI, that's P. So what we have here again is power, like power equals VI. So this is units of power, units of power. It's not a unit of energy. This is a unit of power. So from that analysis, you can see that 5 is going to be the right choice. So then you can see 1, 2, 3, 4, they are all units of energy. The last one, number 5, is units of power. So that's the right choice for problem number 1.